Here we're going to look specifically at two special triangles, the 45-45-90 and the 30-60-90. First, let's look at the 45-45-90. So if we declare this corner to be our 90 degree, the 45-45-90 states that both of these angles have to satisfy 45 degrees. Now the other thing about it is these triangles are special triangles because we assume that their legs, so the opposite and the adjacent legs, have a radius or a distance unit of 1. In other words, they're special not only for the angles that they possess, but because they also fit on the unit circle, which we will be getting to. So with that being said, if we were to use Pythagorean's theorem, one of the things that we would notice is that if my two legs are 1, then my hypotenuse has to be the square root of 2. Now the reason these are special is because it means when we talk about our trig functions, they will always come out to be exactly the same. In other words, the sine of my 45 degrees will always be the square root of 2 over 2. Why? Because no matter which angle we choose, you're still going to have 1 over root 2 and you rationalize. Now that being said, my cosine of 45 degrees is always going to come out to be the square root of 2 over 2. And my tangent of 45 degrees is always going to come out to be 1. Okay, now that's fact, that stays. Okay, so we can use that to help us when we're trying to solve problems. Now with that, we have the major three. We also have the ideas surrounding the minors. So my cosecant of 45 degrees was always going to be the square root of 2. My secant of 45 is always going to be the square root of 2. And my cotangent of 45 degrees is always going to be 1. Okay, so again, we can use these facts to help us. Now, with that, we have another special triangle, the 30-60-90. Now, the 30-60-90 comes from an equilateral triangle, where all three angles are 60 degrees. Where the 30-60-90 comes in is if we drop a vertical line into our equilateral triangle, what happens is we develop our 90-degree angle here. Now, we end up with 60 degrees on the one part, which means the little part is going to become 30 degrees because 60 divided by 2 is 30. Now with that, this also means that instead of just having one set of trig functions like we do for the 45-45 triangle, we actually have two. We have a set that deals with your 30-degree angle and a set that deals with the 60-degree angle. So how does that all work? Well, first of all, this small section, in other words, when we've cut it in half, this becomes a 1. With that, we know the long side is a 2, which makes the vertical here the square root of 3. Now the reason this works is because we assume in the beginning that your sides equal 2 to start with of your equilateral triangle. So we would say 2, 2, and 2 all the way around, which is why this little piece here can be a 1. Now with that, we can look at your trig functions. So let's start with the sine of 30 degrees. So if my 30 degrees is the little angle up here, sine is going to be opposite over hypotenuse. So this is going to be 1/2. My cosine of 30 degrees is going to be the square root of 3 over 2. My tangent of 30 degrees is going to be the square root of 3 over 3. Remember, tangent is opposite over adjacent. and you rationalize. My cosecant of 30 degrees is going to be 2. My secant of 30 degrees is going to be 2 square roots of 3 over 3. And my cotangent of 30 degrees is going to be the square root of 3. Now with that, we can also look at 60. So we can do these same 6 functions, but now what if we look at it through the eyes of 60 degrees? Well, that's going to kind of change things around. My sine then becomes the square root of 3 over 2. My cosine of 60 degrees becomes the 1/2. And my tangent of 60 degrees becomes the square root of 3. My cosecant of 60 degrees is going to become 2 square roots of 3 over 3. My secant of 60 degrees becomes 2, and my cotangent of 60 degrees becomes the square root of 3 over 3. So these are kind of like your fact. These you can have confidence and know that they're never going to change. They're always going to be the same. Now the reason this is so important is because sometimes you're going to be asked to find the exact value without the use of a calculator, meaning I don't want the decimal answer. I want to have the radical answer or the fraction answer. And knowing our two special triangles is going to help with that. First of all, knowing that I want the tangent of 30 means I can automatically draw my 30, 60, 90 triangle. And that is one thing that you're going to want to practice doing a lot to make sure that it becomes second nature. To draw that triangle is very simple. You just simply give yourself a short side and a longer side. We have 30 degrees is your short side, the 60 degrees is the long side, and then you input the values that you have. 1, 2, square root of 3. In doing so, you can then find your tangent by just simply making reference that my tangent of 30 is going to be opposite over adjacent. So 1 over the square root of 3, and you just simply need to rationalize. Square root of 3 over 3. Okay? Now, we already told you that that was fact, but if you forget, this is how you would approach it. Now, we would do the exact same thing with your 45. And so again, you could draw your triangle, but in this time, your two legs are going to be the same size. Both of your angles are your 45. And there you have 1, 1, and square root of 2. So in this case, when I want the cosecant, I am looking for the reciprocal of sine. So my cosecant of 45 is going to be the square root of 2. And you can do that exact same idea no matter what function you are working with. Okay? So that is just a snapshot into your 30, 60, 90 triangles, your special right triangles. So essentially what you want to do is you want to work on making sure that you have memorized or use as reference these two special triangles. They are going to be the biggest help to you no matter what trig you're trying to accomplish. And especially if you're trying to accomplish it using exact values. Remember, exact means not decimal. It does mean fraction or radical form. So I hope you enjoyed this short video on the special triangles of the 30, 60, 90 and the 45, 45, 90. And if you have any questions, please let me know. Otherwise, I look forward to speaking with you next time.